So now if we graph these, it's helpful to have a graphing calculator. If you need to use Desmos, you can also use Desmos. If you don't have a graphing calculator, again, you can just use Desmos. So open up on your computer, or you can open up the graphing calculator app on your phone or an iPad if you need to. So if I go to my y equals, it's helpful if you have a color one that they're different colors. That's kind of a nice thing. And I'm going to use the color here so that you can see the difference between them. So I'm going to start with my linear here, and I'm going to graph the parent function for linear, so y equals x, so just x. And then I'm also going to graph this transformation, x plus 5. Then we hit graph. All right, so the blue is the original, the red is the transformed. So if you look here, we're going to use that intercepting the y-axis as kind of an anchor point. So we know it intersects at 0, 0. Then look and see where this intersects the y-axis. This x plus 5 intersects at 0, 5. So let's think of this in terms of what we know about transformations. So the original intersects at 0, 0. The new one intersects at 0, 5. So what kind of translation is that? How is that moving? Well, it should be moving up 5. All right, let's do the same thing with this square root function down here because that's the only one that they have there. So let's graph the parent function of square root of x. So go back to your y equals menu. Second, square root of x. And then we're going to graph the g of x, square root of x plus 2. All right, and we'll graph. Okay, so the original here is the blue. The new transformed one is red. So again, our square root function here starts, if you look at where it intersects the y-axis, at 0, 0. And then the new one goes through the, well, I guess if we translated this point, right, it's not necessarily going through the y-axis, now it's going through the x-axis. Goes through the x-axis at -2, 0. Okay, so we went from 0, 0 to -2, 0. So what kind of a translation is that? Well, we went from the x value being 2 to the x value being -2. So we went left 2. Okay. All right, now let's try and look and see what's happening with our quadratics here. So since there's 3 of those, we're going to go to y equals. And then we will type in x squared because that's the parent function for all of our quadratics. And first I'm going to look at x squared plus 5 and graph it. All right, so what does it look like that one is doing? So again, if you look at your origin, your original, right, how did that shift? Well, this one, the blue one, it looks like I just took it and moved it up 5. Okay, up 5. All right, now let's take a look at this x minus 3 squared. All right. All right, so quantity x minus 3 squared. And we graph. I like quadratics because it's actually very easy to see how they've moved. So here's our original quadratic going through 0, 0. That 0, 0 point right there looks like it's moved over here. So our graph has moved 3 to the right. Oh man, my pen is lagging. There we go. All right, so we moved right 3. So as you're going through and as we're going through and doing these, I want you to kind of try and compare and look and see how they look different. So like x plus 5, that moved up 5. X squared plus 5, well, that also moved up 5. This quantity of x minus 3 squared, well, that moved right 3. Okay. All right, let's take a look at this negative x squared. So negative x squared. And we don't need to add any parentheses to that. All right, so that one, it looks like reflected across the x-axis. All right. Reflect across the x-axis. All right. So that takes care of our linear quadratics. We've done a square root. Let's take a look at our cubic functions now. So let's do x cubed. And then our first one is x plus 2, that quantity, x plus 2 cubed. All right, graph. All right, so the cubic, it looks kind of like a S almost. Started here at 0, 0, then it moved over to the left 2. So we're going left 2. All right. And then our cubic, x cubed plus 2. All right, so let's compare these two based on what you've seen before. So let's look at these two, number 2 and 3. This quadratic, x squared plus 5, moved up 5. But this quadratic, the way it was written, x minus 3 squared, went right 3. So if in number 6 here, this cubic, it was x plus 2, it moved left 2. Well, but now if we take the x cubed and add 2 to the whole thing, think for a second, which direction do you think it's going to go? So while I type it in here, think about which direction you think it's going to go based on what's happened before. All right, so remember what you thought was going to happen? Is that what you thought was going to happen? Our original moved up 2. So this is an example of moving in the vertical direction. Up 2, like that. All right, so just some things to think about. All right, so if you have your parent function and you're adding something like to the outside of that parent function, like you're just kind of tacking it on the end, like in number 1 and number 2 and in number 7, you're either going to be going up or down, it looks like. Those ones were adding, so you're going up. So if you were subtracting, maybe try one like where you're doing x cubed minus 2 and just see if it moves down 2. And then if you look at ones like, okay, number 3, where you have a quantity, number 6, where you have the whole quantity, and then number 5, where you had the square root of that whole quantity. Well, when it was x minus something, we moved to the right. But when it was x plus something on the inside there, we moved to the left. So that's interesting. And here, just making it negative reflected it. So some things to think about as we move forward. But for right now, go ahead and try your practice with parent functions.